Faculty of Engineering, University of Gajah Mada, majoring in geological engineering. So why I choose geology? It's because I'm deeply interested in understanding Earth's processes, the resources, and history. So what I enjoy most about studying geology is how it combines fieldwork, science, and problem solving to explain the natural phenomena and contribute to society, such as in the motivated to enter this field because a degree in geology opens an opportunity to work in industry such as petroleum, where I can pursue a successful career, earn a good income for me. So studying geology is quite challenging since it belongs to the Faculty of Engineering and it requires hard work rather than relaxed approach compared to some other faculties. So, however, I believe the effort is worthwhile because the knowledge and skills I gain will open valuable opportunity for my future. In addition, one of my favorite activities is playing sports, especially basketball. As a freshman, I had the opportunity to represent the geological engineering department in a competition. That is a Techniciade, where we won the third place, and our faculty, the engineering faculty, is went on to achieve a first place. This experience not only strengthened my passion for sports, but also taught me the value of teamwork and persistency. I also consider myself an easygoing person and friendly person who enjoys making a new friends. Uh, Myself is coming from Jakarta. I find it exciting to be in a new environment like Yogyakarta. Although I am not originally from here, I feel that the people are very kind and supportive, just like the community back home. This has helped me adapt quickly and feel comfortable in my new surroundings. Okay, so that's it from me. We're gonna go to the material right now. Okay, so the introduction of sedimentation to identify and analyze the variation, abundance, and frequency of the different minerals present in sedimentary rocks, providing insight into their composition and formation processes. And the goals is to conduct and provenance determining the origin and source materials of the sediments, to interpret the geological process responsible for the formation, transportation, and deposition. Okay, so I'm gonna explain of you guys about the characteristic of the sedimentation. Sedimentation represent the final stage of exogenic process, which include weathering, erosion, transportation, and deposition. It occurs when materials such as rock fragments, soil, or other particles that have been transported by natural agents like water, wind, and ice are deposited as the energy of the transporting medium decreases or stops. The characteristic of sedimentation are strongly influenced by particle of sedimentation and are strongly such as clay, silt, and usually settle in low energy. So basically, there are environment like lakes, floodplains, or deep marine is in the settings. In contrast, larger and heavier particles such as gravel, coarse, and sand require stronger current to be transported, s- uh, are deposited more rapidly in high energy environment. For instance, in river channels or coastal areas with strong wave. Over time, cumulated sediments can undergo compaction and cementation, forming sedimentary rocks through a process called lithification. This rock displays diverse lithologies such as sandstone, shale, siltstone, and claystone. Depending on the nature of the deposit materials and the condition of the deposition, the development of sedimentary is to transport processes the specific depositional environment. Okay, so the sedimentary rocks. As you can read in my presentation, the sediments are earth materials that accumulate at or near the surface of the lithosphere under atmospheric or hydrospheric condition. When the sediments undergo lithification, they transform into the sedimentary rocks as the diagenesis. As a result, sedimentary rock preserve important records of past environments and geological processes, making them a valuable sources of information in reconstruction Earth history. Okay, so I'm going to explain a little bit more about this. Okay, rocks are one of the most important natural resources that play a major role in the information of the Earth crust themselves. They are classified based on their formation processes, the texture, mineral composition, and one of the main group is the sedimentary rocks. These rocks are formed from material produced by the weathering and breakdown of pre-existing rocks, as well as from chemical reaction or biology activity. Once deposited in layers on the Earth's surface, these materials is undergo lithification, the compaction and cementation, which gradually transform loose sediment into solid rock, like in the Petijon in Indarto 2025. The formation of the sedimentary rocks allows a series of stages beginning with weathering, erosion of parent rocks. The resulting materials are when transport natural agents such as running water, wind, glacial ice before eventually being deposited in specific environment. As deposit continues, pressure and temperature cause the sediment compact and bind together, forming the distinct layers of the sedimentary rocks itself. In general, sedimentary rocks are divided into two main types. Okay, the first is clastic sedimentary rocks, which are composed of fragments of other rock transport and deposited by natural process. The second is non-clastic sedimentary rocks, which form through chemical precipitation or biological activity. Among these, sandstone, shale, and limestone dominate the volume of the sedimentary rocks, accounting for more than 95%. And the classification itself is usually carried out by examining factors such as texture, mineral composition, physical properties, field observation, and such as identifying grain size and noting the dominant rock fragment is in sedimentary or volcanic rocks. Next to the next slide. Okay, the composition of the sediment particles. The clastic particles in siliclastic sediments may include, like I said before, there is a lithic fragment from sedimentary, igneous, or metamorphic rocks, quartz, feldspar, heavy minerals, and other subparticles such as fossils. Right here in the right, we can see the example of the minerals. Okay, okay, there is one thing too. Example of the heavy minerals in the opaque group, hematite, brownish black, no cleavage, flaky like mica, pyrite, yellow is granular, cubic, sometimes striated, and then magnetite. The description is metallic black, isometric, no cleavage, metallic luster, aluminite, brownish black, massive plate-like, sometimes granular, and conchoidal fracture. There is ultra-stable group. The zircon, variable colors, clear yellow, sometimes brown and blue. The prismatic tetragonal features resonance luster, irregular fracture. Tourmaline, brownish yellow, elongated prismatic hexagonal, resonance features luster. Translucent, rutile, reddish brown tetragonal. Okay. There is metastable group, olivine, pyroxene, garnet, apatite, and the others like epidot, zoisite, kyanite, andalusite, and sillimanite. Light minerals, like I said, there is quartz, feldspar, mica. Okay, so how to the determining sediment particle composition? Here's are the steps to determining particle composition. Before microscopic observation, separate light and heavy minerals with heavy liquid method. If not possible, focus on the quartz, feldspar, and lithic fragments. Heavy minerals can be analyzed, use heavy chemical solution. And the tools and materials is the sand sample, small brush, needle, stationery, FS paper, dry tissue, binocular microscope, glass plate, the observation of the procedure. Here are the observation of the procedure, and then I'm going to explain you about the laboratory procedure. Like in the picture, we can see the paper, mineral bread, magnetite, olivine, apatite, tourmaline, and then jumlah mineral, light minerals, quartz, feldspar, and the fossils. Observe and count both light and heavy mineral particles under the microscope for each field of view. Examine around 25 grains with a total of about 100 grains observed, like in this paper. Record all observation in a data table, revert to the provided sample. Here are the example of the diagram Van der Plas to determine the minerals, and then the example of the calculation. Okay, so the provenance study. The use of sediment composition is to identify and analyze the influence various factors such as source material, transportation, process, and the positional environment. Example, like the high quartz, rounded grains, long transport from continental source, beach or desert environment, angular feldspar, lithic fragment, and the short transport from nearby rocks, like river or alluvial fan setting. Okay, the provenance tectonic settings. I'm gonna explain to you about this provenance. Okay, so this model explains how different tectonic settings influence the composition of sandstones by plotting quartz, feldspar, and lithics, QFL. The proportion in a triangular diagram, each provenance has a distinct tectonic environment which leaves a characteristic mineralogical signature. Like you can see in the picture, we can see the stable continental craton is dominated by quartz-rich sandstones, represent old stable continental interiors with a little tectonic activity. Sediments are well weathered and mature. The recycled Oregon and the right, the continent or continent volcanic arc collision produce sandstone rich in quartz and lithics. Sediments are recycled from other sedimentary rocks uplift during orogeny, often associated with mountain belts and thrust system. Block faulted continental basement. Okay, in this part is including the rift system characterized by feldspar, rich hailstone, derived from uplifted basement rocks, and igneous and metamorphic sources indicate the tectonic activity exposing deeper crustal rocks. Okay, so the volcanic island arc produce lithic rich sandstones, especially volcanic lithics, derived from volcanic eruption and erosion of arc-related rocks. Okay, so what I mean for saying that is by plotting sandstone samples in the QFL diagram, we can interpret the tectonic setting of their provenance, providing insight into past geological process. Okay, here are the example of my own work in the laboratory of Sedstrat. You can see lithic, quartz, and feldspar. Lithic is the green one, quartz